Hello everyone, I'm Anushka Sachdev and my teammate is Sumant Kumar. We are final year students pursuing our BTech degree in Computer Science and Engineering from ABS Institute of Technology. We are going to demonstrate the working of a project titled Electronic Health Record Management System. The conventional health record systems contain a very sensitive piece of information and are very challenging to implement and handle and incur high cost due to the investments in training, support and physical infrastructure. Even with such a giant leap from big physical folders to electronically managed records, still most of us find ourselves carrying our medical files whenever we need to visit a doctor. In an era where data privacy is a linguistic metaphor, delegating the responsibility to handle millions of sensitive records to such a system is prone to security breaches and data leaks. This data privacy issue is proven by the fact that according to the 2016 Breach Barometer report, nearly 3 crore patient records were affected, and this number of data breaches has increased since then. It is commonly understood that healthcare providers generate enormous amounts of data in various formats, including reports, financial documents, laboratory test results, and imaging studies. The extensive database being generated in healthcare settings is expanding at a rapid rate. This results in the rise in healthcare costs as a sharing of information between multiple healthcare facilities spread around different places. Now, why blockchain? Blockchain technology serves as a best solution to address all the problems and fulfill the needs. Blockchain, being a decentralized and distributed ledger, it can also impact billing, record sharing, medical research, identify thefts, and financial data crimes in days to come. Implementation of smart contracts in healthcare can simplify things even better. Where invoking, record creation, and validation will be done on blockchain. This paper highlights a patient-driven model of record maintenance using blockchain technology, where smart contracts can be incorporated in future days, making it more potential in data exchange. The rational use of blockchain technology in healthcare is a fact that maintenance of a typical healthcare information system involves various operations mechanisms in place and ensuring up-to-date fields. In a blockchain, data is distributed across a network and there is no single point of failure, leading to an inherent backup mechanism. Also, a single version of data is copied on every node of the blockchain. This reduces the volume of transactions that occur between information systems, thus reducing the burden on the healthcare ecosystem. Now, let us know about the architecture of blockchain. Instead of using the traditional centralized databases, the Ethereum-based blockchain is applied to our design system framework of medical record management to ensure the security of data. The medical records are stored within individual nodes in the blockchain networks by utilizing smart contracts. The automatic smart contracts for the administrative procedure are also designed with the aim of reducing the waste of human resources and speeding up the medical process. The proposed EHR system consists of stakeholders, also referred to as agents in the implemented solution, using smart contracts. There are two agents involved currently in the system, namely patients and the doctors. The agents can obtain the resources such as patient records by using IPFS hashes. The agents are envisioned to access the smart contract and the decentralized storage system through a front-end layer known as DApp. Decentralized application, which directly interacts with the smart contracts with the help of API such as Web3 MetaMask. The blockchain for the project is provisioned by Ganache. The two stakeholders in the proposed solution take part in directly interacting with the app. The patient is one of the stakeholders who can interact with the blockchain with the help of the user interface provided, with which he or she can store information on the IPF and can permit revoke access to or from the doctor, which is another stakeholder. The doctor can view the patient records using the user interface whose access has been granted to him or her. Then he can add to the diagnosis of the patient, which updates the information stored on the IPFS. The three-layered architecture ensures that the data on the blockchain is never directly handled by the stakeholder and even the patient who is the rightful owner of the data. Access control ensures that the data is always being controlled and manipulated by the rightful owner, and only he or she can decide to whom to give the access to the data. Thank you.
Now we'll be moving on to the implementation part of our app to see how the patient and the doctor interact with our app, starting with how they are registered and logged in to our app. For logging in and registering, we have something called MetaMask, which is similar to Google OAuth that helps the user to log in with his or her private key, and also exposes a public key so that others users can react or interact with it. For the users to register, we ask the age, name, and what the user is. So basically, we are asking for if the user is a doctor or a patient. Now we see there is a Ethereum transaction taking place, and that takes some Ethereum to register a patient or a doctor. Now, as we have registered one user, that is a doctor user named Dr. Patel, and as we can also see in the accessible EMR section is empty because we do not have any patient that has given the access to their records to this doctor. Now, to register a patient, we'll have to add a new account into a MetaMask account. So as you can see, I'm changing my account to account 2 for the patient, and now I refresh the page. Now, if I try to log in, I won't be able to log in because the user has not been registered yet. So let's move on to register our patient. So let's give our patient name Freddy. Let's have his age as 21 and yes, patient. Now, for registering our patient, we'll have to pay some ETH. So, as you can see, we are moving on with the transaction. As we can see, the user is now registered. Now, as I've clicked on View Medical Records, you can see we have the name and the public key as the records. So these details are stored on our uh, IPFS network and not on some centralized storage. Now, if I want to give some doctor access to my records, I can simply select the doctor's name and then press submit. For that also, there is a transaction taking place, so we have to pay some ETH. But this ETH is somewhat given back to the user so that the user is incentivized in some way. So now, as you can see, we have given the access. Now, if we try to revoke it, we can also do that, but by just paying some Ethereum. Now, let us give the access to Dr. Patil, one of the doctors, to see what happens at the end of the doctor in the user app. Now we are moving on with another transaction. Now let us just log out. Now, as we can see, we have the access. Now we log out and we change our account from the patient to the doctor. Refreshing it once. Now we can see we have logged in as Dr. Patil, and we can see we have the records. So these are the records that have been stored on the IPFS. Now we can send some diagnosis and some details for the patient so that he can see it. Now if I press submit, I have to pay one transaction, pay some ETH for the transaction. And as you can see, if I press confirm and transaction is confirmed, the access of the doctor of the records has been removed. Now let us go back to the patient's dashboard and see if something has changed there. For that, we change the account once more and let's refresh once. Now, if I log in, I can see Freddy 21. Yes, this is a patient, and this is the diagnosis that her doctor has given. So, this is how our application works and how patient can give the access to the doctors and how the application is decentralized and patient centered. Thank you.